privilege to visit the Turkish Polar Research Center, ITU. I also have a chance to meet many scholars of Turkish polar community. Well, I also like to thank to Professor Burcu Oskoy and other members of POLRED to arrange my trip. My trip was, mostly supported by the Scientific Committee of Antarctic Research. So I'm going to start on a little bit introduction of polar perspective of Antarctic science, and then I'm going to introduce some of our Korean Polar Research Institute, and then our activity in the Arctic and Antarctic. It's a very large topic to discuss, so I'm going to finish on time, hope to finish on time. Okay, let's start on SCAR. As you know, the SCAR was formed in 1958. It's actually a part of third IPO International Polar Year. But previous two polar years mostly concentrated in the Arctic science. The third polar year was concentrated in Antarctic. It's called the International Geophysical Year. It was very, very successful. More than 60 countries involved in that campaign. It's the first time that science research stations established in Antarctic for a year-round station. And since it's so successful, the international organization called the Scientific Committee on Antarctic Research was formed under the umbrella of ICSU body. So actually, original members, 12 founding countries studied. And this is a part of Antarctic Treaty. SCAR is part of big Antarctic Treaty system. The Antarctic Treaty was actually signed right after the SCAR was formed. So now the treaty system was developed. So many different items is added to the treaty system. It's called treaty system. Started Antarctic Treaty, and then the protocol was added in that in 1991, and CAMLA is a kind of fishing agreement, and then Convention of Antarctic Seals and agreement. This six items are basic institution. It's international legal binding members of the system, and there are 3 observers. One is the SCAR, as I said, and then COMNET and CAMLA. This CAMLA is really different. CAMLA Commission for the conservation of Antarctic marine living resources. It's a practical body to implement the CAMLA of so this is a legal binding if this is an observer. And then also there are 8 expert groups in the treaty system. As you know, it's well-known WMO, IHO, IMO. It's all part of expert group within the SCAR, Antarctic treaty system. Okay, so SCAR, back to SCAR. SCAR is say now the 44 members, 33 members, 11 associated members, and now there's 19 international scientific unions also part of the SCAR. So this is all and the COMNET was a support member. The COMNET was actually part of SCAR, the working group as a logistics. But 1988, they separated, working group separated to be an independent organization called the COMNET. COMNET is a more powerful member. COMNET has money. So COMNET is just an organization composed of director of each, director of national institute. So actually, they have all the powers and money. So it's more powerful body at the moment. Okay, this is about the SCAR. And then what the SCAR is looking for. A few years ago, SCAR made a very big survey, make a recommendation for the national program. What is the most important topic for the Antarctic for the next 20 years or something? This is just this one, 6 most important themes to be studied in Antarctic for the next 20 years. example, the ice sheet in Antarctic, and Antarctic history is a paleoclimate, and life science, and then space science, and the human influence. Those 6 topics are going to be the most important things to be studied. They make a very good, very timely suggestion, recommendation for the national priority. And also, to perform this science, the COMNAP and SCAR together suggest this Antarctic roadmap challenge. So what kind of challenge you are going to meet to perform such a big science topic? First, like the technology, we need the technology, new technology, and we need the infrastructure, we need the access, how to access the Antarctic. And of course, it's very expensive to do science in Antarctic. So actually we need international collaboration to do that. Because not any one country cannot do all any science related with the Antarctic. So this is the 5 most important recommendations made by SCAR. This is two big pillars. One is horizon scan, 6 biggest theme of Antarctic science, and also the roadmap challenge. These 2 big pillars now to working on Antarctic science. Okay, back to Antarctic. There's a satellite mosaic of the Antarctic continent, and then also you see a lot of small circles, all the stations in the Antarctic. There are now 40 year-round stations operating by 21 countries at the moment. And why there's so many countries running the stations, such a coldest and driest and windiest place in the earth? Why? I think my simple answer is the size of the continent. It's much bigger than China. China is one of the biggest countries in the world. Bigger than China, and even bigger than India. So we call the size of Antarctica is about the same size of combination of China combined and India. So it's 10% of continent of the Earth. So what I mean is, if we like to understand about Earth, we should understand about Antarctica. So it's the least known area, least known continent in the world. And not only the size, I don't mean size is the most important part. Size is very important. But what else? What else? Most important issue now is about the climate, environment, our environment. Many of you probably see this before. This is a risk analysis made by World Economic Forum. It's known as a Davos Forum, right? And every year they make a big, survey. What's the most important? What's the biggest risk for human body in the future? If you see, starting from 2007, 2010, there's a lot of blue ones here. Blue. Blue risk means economy. Economy will be most important, the biggest risk for human body for the next few years. Economy means economic crisis, regression, recession, and economic inequality within country or within internationally. But after 2010, you see a lot of green one. See, green one means environmental issue will be the most important risk for human body for the next 20 years, 10, 20 years. The green one means climate change, extreme weather, like flooding and warming and water supply. Everything related with the environment will be the most important risk for human body. Why Antarctica or Arctic is so important for the environment? Obviously, we know there's many things related with the environmental changes of the Earth. For example, warming is most well known, global warming, and sea level rise, and ozone hole, or ocean acidification are all a part of global change. But mostly we are we're very well know about global warming. It's most well known. And if the world is warm, obviously we expect some sort of glacial melting. We expect, right? It's not evenly melted around the Antarctic. So some areas much more melting is going on. The west side, this is more like a Pacific side of Antarctic. A lot of melting is going on. The East Antarctic, not very much. Some areas, thickening of ice is also observed. So we didn't know that how much melting is going on at the moment. A very recent paper called from 1992 to 2017, that 3,000 billion tons of water melted from the Antarctic continent. It's very recent estimation, very rough recent estimation. So, related to the global warming, we have very much interest in how much actually melting is going on in Antarctica, because it's directly to sea level rise, right? So how much sea level rise we can expect? This is expected flooding if the global warming and Antarctic ice is going to be melted. We estimate the East Antarctic ice sheet. We estimate about 60 meter sea level rise we can expect if all in East Antarctic rise is going to be melted. And the West Antarctic ice sheet is 5 meter effect. The Greenland is 7 meter effect. So in total, if all the ice is in the Earth is melt, more than 70 meters of sea rise we are going to expect. As you see, Istanbul is about, I found in the internet, Istanbul is the average altitude is about 40 meters. It's just like so. You're going to be underwater very soon if it's continues going on in the melting is going on. And also, you see many of biggest cities in the world, like New York, New Orleans, Shanghai, London, are all very, near the sea level. So it's going to be a major catastrophe for the human body in the future. Okay, the other point, we got very important information from Antarctic ice. You see here, many of you probably you see this data before. Scientists drilled more than 3,500 meters of ice from the center of the continent and analyze it for past climate changes. 0 means at the present time, 800 means 800,000 years of history. The center one is how the temperature changes. You see, we have a lot of high temperature and low temperature. This means the glacial ages, it's the interglacial. So we are now here, the middle of big glacial age. We are living in one of the interglacial ages. Here, right here. So from this data, we can, we can see that it's very regular pattern of glacial periods coming, like 100,000 years, very regular pattern. Ice, interglacial and glacial is repeating. Also, we see a very similar pattern of CO2. We can get the gas from the ice, and that we estimate the previous old days atmospheric content. So it's very similar. If the temperature is going up, and the CO2 content is also the same pattern, and the methane too. So we never know what now global warming is part of natural changes or is a man-made changes. We never know, but at least we can say that present day is very abnormal because CO2 range is out of boundary last 800,000 years. Almost all, I mean, CO2 content is about below 280 or 270. Is a natural, boundary of CO2 content. But now, present day, we have 400 ppm of CO2 already. So it's out of range of natural changes. So probably human being made something on this world. It's quite clear. The other importance we know from the Antarctic is this. Is a current of the sea current, ocean current, and this ocean current is very important. All the oceanography specialists know that it distributes the heat from low latitude to high latitude. But this is kind of conveyor belt to bring the heat from the low latitude to high latitude. But this conveyor belt, there is 3 engines, so-called engine, to make this conveyor belt running. One is in the North Atlantic, 2 in the Antarctic. One the Ross Sea, the other is the Weddell Sea. So this is the location where the deep current was generated. If this kind of function is stopped, you may be very big trouble within the energy circulation in the Earth. So there's many important criteria why Antarctica is so important for the Earth's climate. Okay, then the KOPRI, where I come from, is located in Incheon. It's Incheon area. It's very close from the airport. So, which one is up? This is the international airport, and our institute is here, so pretty close. 20 minutes drive from the airport. You can reach the KOPRI. And our institute is working with the 4 major research platforms. 2 is in the Antarctic, one is King Sejong Station in the peninsula. The other new station in the Ross Sea area, the Changogo Station. This is actually at the Pacific part of Antarctic. This is the Atlantic part and Indian part of Australia here. And in between, we have ice-breaking research vessel called the Iron, and we have a research facility in the Arctic too. This is our first station in King George Island, established in 1988. This is the 30 years anniversary of our old station. And a big renovation was done. This is a big new building. It was built instead of old buildings. We removed some buildings and make this two-story big building. And the other is Changogo Station. Is located in the Terranova Bay in Ross Sea. And this station is built in 2014. And the way of giving support is to buy ice-breaking ship. We move the ship as close as possible and bring everything, unload everything on the sea ice, and then bring it to the station. So it's a year-round station. There's now 17 members stay for winter. It's in the middle of winter. It's the very hardest part of the season to stay. Inside the station is a very well equipped. Like we have greenhouses. It's good enough to supply fresh fruits for the winter season. 17 members, and we even have a screen golf like this. So they enjoy screen golf instead of green beer field. And how to get there is directly south from the New Zealand. It takes 8 days one way by ship. It's a very normal way. If you're very, very quick way to go, you can fly from New Zealand to our base by this big aircraft. It is a civilian version of C-130, and this is our station here, and this is Italian station, Italian summer base, Marisco station here. And in between there's a very wide flat area. This is a sea ice actually. So plane and the sea ice is 2.5 meter thick ice. The plane is safely landed. So every year from late October to late November, only 1 month in a year, we operate about 10 flights. Because of after November, the sea ice getting thin, so we cannot operate aircraft anymore. So why we choose the site is our station is located in the coastal area, and it's a very ideal place to study many aspects of science. For example, we have a large outcrop of rocks in probably within 100-kilometer range. It's a Transantarctic mountain. It's one of the longest mountains in the world. And we have behind that mountain is a very, very wide, very thick ice sheet. We have lots of study on geology and glaciology and meteorite searching, as well as astronomy and all sort of science, including the ice core. One of the examples in meteorite search, we had 2007 we started the meteorite searching, and now collected more than 1,000 meteorite from Antarctica. One of the rarest one is this one. We found the 2013 is a lunar meteorite. This piece of rocks come from the moon, so it's very valuable piece of rock. The biggest meteorite so far we have is a 36 kilograms. It's a huge meteorite. It's one of our collection. And we have a geological mapping program in the Victoria Land area every year. So every year at least 5 or 6 geologists make a field camp like this and do a lot of field research in the area. And also this, as I mentioned, is a very nice area to study various part of glacial phenomena. For example, the station is here, and about 100-kilometer range. We have very big ice tongue glacier. So, continental glacier slow down, moving down toward the sea. Ice tongue is very big ice tongue and ice shelf, and then we have active volcanic mountain very near. So this is a very ideal place to study about movement ice. So we have a lot of monitoring site, running a monitoring site to study about the interaction between ice and earth, ice ocean, air and ocean, acid, all kind of interaction between ice and other materials. So we have a very intensive monitoring network now installed. So one of the amazing scene we found is in the Nansen Glacier. It's very close from our station. You see in the summer seasons, a lot of melting, surface melting is going on. Huge melting, surface melting is going on in the area. So one of the most fast warming area in the eastern part of the country. So as I told you, this is our station is here, radar ski ice down this Ross Sea area. So we installed so many monitoring stations like GPS and earthquake seismometer and weather station and OBS down there, and morning very intensive monitoring station for the movement of David Glacier. It's called Big David Glacier. It was so successful. And also we are doing a lot of oceanographic survey by using our ice breaking vessel, Aeron. Aeron was launched in 2010. It is about 85 people can be on board, and performance is about less than 1 meter thick sea ice. We can continuously break the ice with the speed of 3 knots. It's a very powerful engine. And every year she is about 110 meter long. Every year she has a voyage to the Antarctic and Arctic. It's one of the busiest ships in the world now. So for example, last season, she traveled from Korea to Antarctic through Hobart, Australia, and make a 3 voyage from New Zealand to the Ross Sea, to New Zealand to Amundsen Sea, and then come to the Peninsula area and back to Korea. Now she will leave to the Arctic, this coming Friday, 2 days after. She will start to move from Korea to the Arctic. She will stay for 2 months, studying on the Chukchi Sea, Beaufort Sea, and East Siberia Sea. So in the Antarctic oceanographic world, see they have a big expedition every year on the Ross Sea area. A lot of 7 Coring and Mooring, and it's kind of international work with other international partners. Sometimes we do marine seismic, multi-channel seismic work in the sea too. And Amundsen Sea is also a very big part of our oceanographic project. We visited so far 6 times to the Amundsen Sea area. Amundsen Sea is, is one of the most rapidly warming area in the whole Antarctic. They made there are only few ships in the world that can actually visit this area in summer season. Last few years, she visited many times near the Pine Island Glacier. It's gone. The whole ice glacier is gone. And now the main interest moved from the Pine Island Glacier to the Twig Glacier. So now you probably know that big international project between US and UK is working consensually on this Twig Glacier. So we are going to part of that too. So during this cruise, put a lot of mooring and CTD testing and kind of glide AUV monitoring also was done for the from 2010. And as I told you, it's the most rapidly warming area. In the West Antarctic, in the peninsula area, the reports show that last 50 years we measured about 2.5 degree rise in temperature. 2.5 is a very high rate of increase. And from the Pine Island Glacier area in Amundsen Sea, we found that the melting, majority of melting is going on beneath the ice shelf rather than surface melting itself. So it's something called deep water, warm water coming into the ice shelf, and then a lot of melting is going on below the ice shelf. It's a major mechanism of melting. So this shows many things. If nobody knows before where the melting is going on actually. Our melting major mechanisms underneath its ice shelf. Also, the other important point is, so far we believe that if the Antarctic glacier melting is going on, maybe it's very slow, right? It's only 3 millimeters per year, so very slow rate. So within our generation, we don't worry about very much. But actually, it's not. Many new science suggest that in some point of the threshold, if this ice shelf is gone, very abruptly, whole ice glacier collapse. It's very possible. So sea level rise is not just continuous, slow, continuous. At a certain point, it will be very fast. Can be. So we have a lot of interest in how the melting is going on, what the mechanism of this ice shelf moving. The other project is I'm not going to introduce all projects we're going, but few big projects I'm going to introduce. This is it's very related to the chemical activity. This ROS is a very important area for biology. See here, ROS is a place for the 45% of weather seals, plankton, and 50% of Antarctic krill, and 30% of Antarctic snow petrel, and it's kind of very important area for the Antarctic biology. So we have a very long-term plan to monitor this biological activity, especially along the coast of the western sea, Ross Sea. Especially concentrated on Adelaide penguin monitoring. So Cape Washington is very near from our station. It's about 30 kilometers from our station. It's one of the biggest emperor penguin colony in whole Antarctic. When we visit here, this is very funny animal. Right? It's very friendly and it is really animal of curiosity. It's very curious. We come, usually visitors very fast and see us. And also, this is the animal, they don't fly, so they like to fly. So they line up like this, waiting for the fly. It's whenever we visit, we see the same thing happening. Really interesting animal. Also, the other big project we are working on is inland traverse plan. We're starting from our base, moving toward inland, about 1,500 kilometers moving inland. Final goal is to make a drill, ice coring more than 3,000 meters. We're pushing every year, moving toward the plateau. So far, we up to this point, 500 kilometers. It's not only 1 or 2 vehicles, a caravan of vehicles and fuels and everything. So it's a huge amount of effort is needed. With the aid of radar, ice radar, below the helicopter, and the GPR also, because many crevasses formed here, so it's very dangerous. We should move very slowly, especially up to this point. But after 300 kilometers, it's pretty much flat, so it's very easy to move from that point. Okay, go to the Arctic. As the previous speaker said, Arctic is also a very important part of our planet because it's very big. Arctic Sea is more than 4 times the Mediterranean. Huge ocean, right? And it is mainly covered of sea ice normally, except the summer season. And also the other important character of the Arctic Sea is continental shelf is very, very wide. More than 50% of the ocean is composed of ice shelf. Especially, see the Russian part? Continental shelf is very, very wide. Deeper parts, more than 4,000 meters deep, but a lot of wide continental shelf, you can see. And normally covered by 2.2 or 3 meter thick ice during the winter season. Summers are melting is going on. So also Arctic is very important in global warming. As previous speaker said, see the last 100 years, we see most fast warming area in the world is Arctic. It's 2.5 times faster than an average of the Earth's warming. So, if the warming is going on, obviously we expect sea ice is reduced, very rapidly reducing sea ice. So by 2035, we don't, at that time, we don't see any ice in summer season in the Arctic. Very fast warming and decreasing of sea ice. But we have a very big interest on what's going on in the tundra and below the sea surface. That is a mechanism of methane gas. It's a bunch of methane deposit on the tundra, and there is the Arctic sea surface below the Arctic sea bottom. And you know that methane is very effective greenhouse gases, more than 28 times more effective greenhouse gases than CO2. So we are very much concentrated how much methane has come from the Arctic part. We did it in human, we don't know exactly how much is now coming from Antarctica at the moment. You see, this is a picture we took in our cruise in the Arctic. See, as a lot of methane is coming from the sea bottom. Many of them probably absorb the seawater, but probably some of them probably coming into the atmosphere. Yes, this methane also feedback to the global warming of atmosphere. So it's make a kind of feedback mechanism of warming, accelerate the methane gas head rate, and then accelerate the warming again. Not only the warming of the global warming problem, but also it has a local impact in Korean Peninsula, not only Korean Peninsula, but the northern hemisphere in general. Like sometimes in New York, and Europe, and Korea, sometimes a very cold wave comes from the Arctic. Mainly because of this cold wave, we call that Arctic oscillation. We believe that the cold wave is very closely related with the sea ice crossing in the Arctic. Recent studies show that sea ice decrease very closely related with this cold waves to the northern hemisphere. And not only the bad impact, there's good impact too. Sea ice flows in the Arctic have a very good impact, like northern sea route. From the Europe to the east, there's a sea route. If there's no sea ice, there's a very short way approaching to the far east. For example, we see a lot of save in the track distance, and also obviously time and save and fuel. It's really in the near future, more and more traffic will be done through this northern sea route. But not only the sea route itself, we have very interest in the Arctic resources. So far, Arctic, this is a Greenland here. This is a Canada and US, and this is a big part of Russia. And still, the Arctic contains more than 13% undiscovered oil in the world. But more than that, that 30% of global natural gas is deposited in the Arctic Sea. So especially like Korea, we don't produce any energy sources in our land. So we need the energy from outside. So this Arctic energy source is very good, very important for our economy. So for that reason, we have very strong international interest in the Arctic. So we are sending a ship every year, as I told you before, should travel through the Bering Sea and working normally the Bering, Chukchi, and East Arabian Sea. For every year, she visit there, make a lot of oceanographic survey. One main topic is on the, I told you that methane gas hydrate in the Arctic Sea is one of the main projects. And also, we are maintaining a station in the Arctic. One is in Svalbard. Ny-Ålesund is here. Ny-Ålesund is north of Norway. It's a very good place to study and located in the high Arctic. It's a very good place to study natural phenomena. It's located in the north. It's very high north. But compared to the Antarctic, it's pretty warm there in summer season. Korean station here. We have a neighborhood, China. And Korean Peninsula very near China is very closely located. Indians also here. And Japan is stationed here. There's also UK, Italy, and German, French station. So it's pretty much international town. And except not only the station in the Svalbard, we maintain a couple of monitoring stations in Canada, Cambridge Bay. They have a very big campaign they make a very good facility in Cambridge Bay to recruit more international partners in research. And one in the Alaska Council and in Jacksonville, Maryland. So we are maintaining a lot of circumarctic monitoring site, several of them in the Columbia and Arctic Ocean. And Arctic Council again is a very interesting organization. It's a fairly young one, very young, 96. Its members only 8 Arctic countries, including 5 Arctic coastal countries, and now 13 observers, including Korea. We are now a part of a permanent observer from 2013, and 13 intergovernmental organizations, and 13 non-governmental organizations, and 6 Arctic indigenous community. It's quite a complex international body. But anyway, this is the only governmental organization who have concern on oil control on the Arctic at the moment. And recently they formed a 6th working group under the Arctic Council. So this is a fairly large number of groups. They have a lot of activity. So our scientists normally participate in one of these, many of these working groups to work with, to study with other part. So I'd like to conclude that, as you see here, this is one of the Arctic cruise. We took this picture. You see many nationals involved in our Arctic cruise, our own Arctic cruise in the summertime in the Arctic Sea. So obviously, this international collaboration is our heart of KOPRI, our institute quarter. So if any of Turkish scientists also like to participate in, you're more than welcome to be a part of